video, we are going to talk about vertical and horizontal translations. How the graph of a new function is the graph of a parent function that is being shifted up and down or left and right. Let's first talk about the vertical translations. Given a function y is equal to f of x, let k be a positive number. Then we have two scenarios. The graph of y is equal to f of x plus k. So what it means is we're just adding a positive number k to the parent function f of x. So the graph of that function is the graph of the parent function f of x being shifted k units upward. And similarly, y is equal to f of x minus k is the graph of f of x shifted k units downward. So let's look at part A. We have g of x is equal to x squared plus 2. So first of all, the parent function is x squared. X squared is the parent function. So we know what the graph of a parent function looks like. It's a parabola with the vertex touching the origin. And notice that I already marked some critical points on there. So here we have k. So remember, this is a plus 2, so plus k scenario. That's going to show that the graph of x squared plus 2 would be the graph of x squared that is being shifted up 2 units. So this means up 2 units. Okay, so technically we could just move the whole graph up 2 units like this, but it's not going to give you a more precise graph. So even though we are sketching, but we're trying to be as precise as possible. So instead of shifting the whole graph, we are going to transform each point on the parabola here, well, a few points on the parabola, to new points. So some of the critical points that I'm going to pick to transform are 0, 0, 1, 1, and 2, 4. All right, to transform to new points, we are going to keep the variable x the same, and all you have to do is just add 2 to the y coordinates. So keep all the x's the same and add 2 to all the y coordinates. So we have 2, 1 plus 2 is 3, and 4 plus 2 is 6. So let's plot these new points. We have 0, 2, 1, 3, 2, 6. Of course, you can transform more points if you want. I find that I only need 3 points. That would give me half of the parabola, and then I know that the parabola is symmetric along the y-axis, so I can just reflect the points on the other side and just kind of get a symmetrical shape here. So I chose, so when I reflect, I would have -1, 3, and then -2, 6. And now you can connect the whole thing and get the whole parabola. So now you can see that the pink graph is the graph of x squared plus 2, and then the blue graph was our original function or parent function, which is the graph of x squared. And the pink graph is evidently the blue graph that's being shifted up 2 units. So let's make a little note here. So when you transform points, you will replace xy with the point x and then y plus k. Just add k to all the y coordinates. So let's look at the second example here. We have h of x is equal to absolute value of x minus 3. So I notice that the parent function here is this absolute value of x, and that is a V shape. And some critical points that I would choose is 0, 0, 1, 1, and let's say -1, 1. Okay, so similarly, when you transform these points, you are going to replace the coordinates x, y with keep x the same and subtract k from all the y coordinates. So here in our case is negative minus 3. So the new points will be 0. Let's just keep all the x coordinates the same. Okay, y coordinates will become 0 minus 3 is negative 3, 1 minus 3, negative 2, and another 1 minus 3 is going to be negative 2. So 0, negative 3, let's plot these points. It's going to be here. 1, negative 2. So 1, negative 2 will be here, and negative 1, 2 will be here. And then you can just connect, and that will give you the V shape. And that will be the graph of the function absolute value of x minus 3. And as you can see, it is technically the blue graph that is being shifted down by 3 units. Now let's talk about horizontal translation. Given a function y is equal to f of x, let h be a positive number. The graph of y is equal to f, and then in parentheses we have x minus h. It's the graph of y is equal to f of x, shifted h units to the right. So I want you to notice that with the vertical translation, when we add the constant k or subtract the constant k, we're doing that directly from the function f of x. But with the horizontal translation, we are actually subtracting and adding h directly from x, not from f of x, but from x. So there's a huge difference there. The graph of y equals to f of x plus h is the graph of the function f of x shifted h units to the left. Notice that it sounds sort of backward. When you subtract h, the function is actually shifting to the right. And when you add h, the function is shifting to the left. And to transform points, we are going to keep all the y coordinates the same. So you are going to replace xy with keep y the same. And then as for x, we are going to add h to x. And as for shifting to the left, we're going to transform the points xy, keep y the same, and then we're going to subtract h. And that will indicate the left shifting. Okay, so let's do this example. So just to give you an idea of what's going to happen, so let's say we have the parent function being a parabola. Shifting left or right will mean that the parabola will be on this side or on this side. Okay, so that's what we're going to see. So part A, we have x plus 3 squared. First of all, determine that the parent function here is the x squared function. So let's just put it here. And determine 3 critical points. We can use the same thing as before. So 0, 0, 1, 1, and 2, 4. All right, transform. Keep all the y's the same. Keep all y coordinates the same. And as for the x coordinate, now this is plus 3, so it's the scenario where the graph is shifting left. So we're going to replace all these x's here, all these x's actually, by subtracting 3 from the original x. So we're going to take x minus 3 every time. So 0 minus 3 is negative 3. 1 minus 3 is negative 2, and 2 minus 3 is negative 1. Plot these points. So negative 3, 0. Negative 2, 1. and negative 1, 4. And of course, just like before, we know that the parabola is symmetric, so I drew a vertical line through the new vertex there, the point negative 3, 0, and then I just reflect more points on the other side. And that should give me a parabola. So this right here is the graph of x plus 3 squared. And the blue one, of course, that was a parent function, the x squared function. Let's try another example. So in this one, we have h of x is equal to square root of x minus 3. So the parent function is going to be the square root function. And we know the square root function looks like this. So some critical point 0, 0, 1, 1, and 4, 2. So we're going to transform each point, but first let's see how the function is shifted. So the square root of the graph of the square root of x minus 3 is the graph of square root of x that's being shifted to the right 3 units. To the right 3 units. I'm going to make a note in part A here that this is where it shift left 3 units. Okay, so shifting right 3 units means that when you transform all the x coordinates, we're going to add 3 to all the x coordinates there, and we're going to keep all the y coordinates the same. So 0 plus 3 is 3, 1 plus 3 is 4, 4 plus 3 is 7. Let's plot these points. So 3, 0, 4, 1, and 7, 2. 7 is about here, and 7, 2 is about here. So this is the new graph. That pink graph there is the graph of square root of x minus 3, which is the result of the graph of square root of x that's being shifted to the right 3 units.